Let's move on towards lecture number 15 of matrices. So this is the property which we are going to learn in this class, this property number 6. So if A is symmetric matrix, suppose A is symmetric matrix, then what will happen? K is also symmetric matrix where K is any scalar. Scalar means constant. You already know. What does it mean by scalar? Scalar means constant. Okay. So if A is symmetric matrix, then K is also symmetric matrix, that is constant. If you multiply the matrix by a constant, then that particular entity is also a symmetric matrix. Okay, so A is a symmetric matrix since this symbol is since. So since A is a symmetric matrix, so A transpose is equal to A. We already know from the definition of symmetric matrix, A transpose is equal to A from definition. Let this be equation number 1. Let this be equation number 1. Now we have to prove that K is also symmetric matrix. What do we need to prove? We need to prove, it is already given in the question that K is also symmetric. So we have to prove that K is also symmetric matrix. Now Ka whole transpose. Okay, in order to show that K is also symmetric, in order to show that Ka is also symmetric, we will need to show that Ka whole transpose is equal to Ka. Okay, only then we can say that it is symmetric matrix. Okay, so we have to prove that Ka whole transpose is equal to Ka, only then it will be proved that Ka is symmetric matrix. Okay, now Ka whole transpose is equal to K times of A transpose. This is the property we have learned 3-4 lectures ago. Okay, prior to 3-4 lectures, in some 7th or 8th lecture we had learned this property that Ka whole transpose is equal to K times of A transpose. We have learned this property, right? Now this is from property, this expression is from property. Now from equation 1 we know that A transpose is equal to A. From this equation 1 we know that A transpose is equal to A. So substitute this A transpose with A. So I have substituted that A transpose with A. Now have a look at this. Ka whole transpose is equal to Ka. What does it mean? Ka whole transpose is equal to Ka implies that Ka is symmetric matrix. Obviously, if Ka whole transpose is equal to Ka, if you consider this Ka to be a matrix C, let us consider that Ka is a matrix C, then C transpose is equal to C. Okay, so as C transpose, when C transpose is equal to C, C is symmetric. So C is equal to Ka, so Ka will be symmetric. Okay, so Ka is a symmetric matrix. So this was the property which we learned in today's class. Thank you very much.